see about that. Don't count on it, though, right? Prepare as if we aren't going to do anything, have anything like that. All right, here we go. So, intercept form. Okay, you'll see here that this doesn't look quadratic, does it? Why doesn't this look quadratic? What's missing here? Yes, a square, okay? But looking at what's written here, are we going to end up with a square?
Yes.
Yes, why? Because we have an x and an x, and they're being multiplied, and we're going to get an x squared. If we were to multiply, like FOIL this out, you guys remember doing that? Okay, we would do the x times the x, and then x times the minus q, and the minus p times the x, and the minus p times the minus q there. Okay, there's so many letters in there, it's kind of hard to keep track of. But you can at least see that those x's are going to multiply. We're going to get a quadratic relationship here, and so the graph is going to be a parabola. Okay, so here's the thing to remember. The x-intercepts are p and q. Okay, notice the formatting here. It's x minus p, but the x-intercept is positive p. It's x minus q, but the x-intercept is positive q. So just like we were talking about with vertex, right? That number that's inside with the x in vertex form, right? You remember that? Let's see if I've got that here handy real quick, or real slow, because that's just how I roll sometimes. Let's see. Thought I had it handy. Maybe not. Maybe not. Aha, there we go. Okay. Remember in vertex form, right? That h, okay, it says minus h, but it's just positive h. That's your x coordinate. So the same thing here, okay? The zeros here are going to be the opposite of the number that's in with the x there. The opposite of the number that's in with the x, okay? It's positive p and positive q in that case. Okie dokie. All right. So then let's take a look at some of these here, okay? How can we find some of the other important pieces of information? Well, the axis of symmetry is halfway between p and q, right? Because the parabolas are symmetric. If we have this 0 and this 0, all right, we can then add up the p and the q there and find the midpoint or the average of them, and that'll give us the axis of symmetry right here. Okay? What other important... I'll get you in 1 second, Tyler, here. I know what you're going to ask. What other important piece of information shares this x-coordinate with the axis of symmetry? What other important piece of information about our quadratic shares this x-coordinate with the axis of symmetry? The vertex. So, how do we find the axis of symmetry? Use x equals p plus q over 2. How do we find the vertex? Use x equals p plus q over 2, and then plug in to find the matching y value. Okay, Tyler, yes, you can go if you need to. All right, so let's take a look at an example right here. Okay, first of all, do you recognize here that this is in intercept form? Yes? There's our a. Okay, there's our x plus 3. There's our x minus 1 there. Okay, so according to this then, if we have x plus 3, what is our x-intercept from here going to be? Not positive 3. Negative 3, right? Remember, it's the opposite there. So x equals negative 3 is one of our x-intercepts. According to this one, what's our x-intercept? Positive 1. Again, the opposite. Very good, Grayson. Yes. Okay, we can go ahead and plot those over here then. Negative 3, 1, 2, 3. And positive 1, 1. Okay? Now, some of you guys will be able to eyeball the halfway point. Right? Some of you will be able to eyeball what the halfway point is here. So again, we have this x, we have the x-intercept here at negative 3, we have the x-intercept at 1. Where's our axis of symmetry going to be? At what x value? Negative 1. Very good, Trey. Yes. Is that what you're going to say too, Jackson? Yeah, excellent. Negative 1. So if you can eyeball it, guess what? You don't have to do the calculation. You can just see, oh, there's our axis of symmetry right there. Right? Just from the midpoint. But let's just calculate it just to make sure that we are right, because, of course, sometimes our eyes can deceive us. So we'll put negative 3 for our 0 plus 1 for the other 0 all over 2. Okay? How should I simplify this? What goes together now? Well, how does it simplify? What goes together? Negative 3 plus the 1, which is what? Negative 2 all over 2. What's negative 2 divided by 2? Okay, negative 1. So Jackson, Trey, anybody else that saw it, You guys were right, okay? Your eyeballs were right. When Tyler comes back, yes. Unless it's an emergency, okay? All right. So there it is. All right. Now, we've got the x coordinate for our vertex, or we have the coordinate, the x value for our axis of symmetry there, right? It's x equals -1. But how can we find the matching y value? What do we need to do with this x value to find the matching y coordinate here? What do? Plug it in. So right in here, see why they left blanks? For the x values there, we're just going to plug in -1 and -1 there for the x. I know you're going to say that, Alex. Thank you. That was good. -1. Okay. At this point, you can type it in your calculator, or you can just simplify it. So I'll just do it here for us. -1 plus 3 is... What's -1 plus 3, folks? 2. What's -1? Take away 1. -2. So we got 2 times 2 times -2. -8. Too many 2's. Well, you just added another one, didn't you? Too many 2's. All right, -1, -8. 1, 2, 3, 4, 5, 6, 7, 8. There's our vertex right there. Okay? Yes, Grace.
How'd you get the number to the right side?
This right here?
Above it.
Right here?
Yeah.
Do you understand where this came from?
No.
Yes?
No.
Do you understand where this came from?
Yes.
Okay, it's just our x coordinate for the vertex. Okay? What we're going to do then, how do you find a matching y coordinate if you have the x coordinate? You plug the x in, find the matching y. So that's what I did. I plugged -1 in for these x's right here, simplify it, and we get -8. And so that's the coordinate. Okay, now, at this point, we have enough information to graph. Okay, it's up to you if you want to get more points or not here. I don't know. I mean, I like to get more points sometimes. That's just me, so I'm going to do it, okay? Because, again, I don't like having just 3 points. So I'm going to put my vertex here of -1, -8 in. And, again, I'm going to do 2 points before, so we'll do -2, -3, and then we'll do 2 points after, so 0 and then 1. Okay, I'm just going to do my table just to see here. Okay, I plug in, let's see, when I do, I'll just use my calculator to do this, just to save on some time here. Okay, so again, in my calculator, I'm going to type 2 parenthesis, let me go up there, 2 parenthesis, x plus 3 parenthesis, close, or sorry, another parenthesis, x minus 1, like that. See, you can type in the whole thing, just like you have it right there. Go to your table. Okay, and there's -3 is 0, which, duh, we already knew that because it's a 0, right? So I didn't really need to do that, but oh well, there it is. -2, -6. 0 gives me -6 as well, and then 1 gives me 0 because, again, duh, our x-intercept is 1, so it's 1, 0, right? So there, I just got a few more points for me. -2, 1, 2, 3, 4, 5, 6, and then 0, -6 as well. And now I'm going to connect the dots. Okay. There we go. Okay, and there's our parabola. Question? Oh, okay, perfect. Here, I'm sorry, Erica. Forgot about you. There's that, and I'll take that. Thank you. Sorry? Yes, they should be back by tomorrow, absolutely. Okay. I'll either return them to you in class, or I'll return them to you in set, or one of the other teachers that pull you will return them to a set if you get called. Okay. There it is. There are those x-intercepts, right? They cross the x-axis. We also have the y-intercept here. What's the y-intercept here? -6, or 0, -6 if you like. It's where it crosses the y-axis here. Very good. Okay. It's concave up, right? Or it opens upward, which makes sense because, again, we have that positive 2a value like Grayson was pointing out earlier. Okay. So, now that we also know all 3 forms, right? Now that we know all 3 forms, standard, intercept, and vertex, we're also going to start learn how to translate between the different forms. Okay. For right now, we're going to worry about just changing into standard form. Okay, now what's standard form again? Do you remember? It was the first one we learned. ax squared plus bx plus c. That's right. So what do you think we should do here to change this into standard form? What do you think we should do? Multiply it out. Exactly right. All we're going to do here to change this to standard form, multiply it out. You guys remember how to multiply this out? Okay. We're going to take this x plus 5 here and multiply it with the x. And we're going to take this x plus 5 here and multiply it with the minus 8. Okay, we did this at the end of 1a or near the end of 1a, if you remember. So it'll be x times x plus 5 minus 8 times x plus 5. Okay, again, I just distributed the x plus 5 to the x and to the minus 8 there, so I get this. And then how can I continue to simplify here? What should we do? What do I need to do here? Distribute the x. And what do I need to do here? Distribute the negative 8. Okay, what's x times x? X squared. What's x times 5? 5x. Okay. What's negative 8 times x? Negative 8x. And what's negative 8 times 5? Negative 40. That's right. Okay, is there anything else we can do here to simplify this? Yes, what? Combine like terms. The 5 is like with the what? The minus 8. So we'll have x squared still, but then that becomes minus 3x, and that becomes minus 40. Okay? And there it is now in standard form. Okay? So we took from Intercept, we made standard form. Okay? You guys were doing this in 1A. You just didn't remember. I mean, sorry, you didn't know that you were doing Intercept to standard form. We did this in 1A.
So, like the first part, I was going to mention those parts. In the first part that you did,
Yep.
instead of doing that, I just did the first x times x minus 8 and then 5 times x minus 4.
That's fine too. Yeah, yes. Okay, so let me show you that alternative way here. So what Alex is talking about here is he did x times x plus 5. Nope. You did x times x minus 8, you're saying?
Yeah.
Okay, plus 5 times x minus 8. Yes, that will also simplify down to the exact same thing here. Yep. So it's your choice which one you want to distribute there. Okay, your choice there. Okay. Other questions on that? All right. What do you think we need to do here then for vertex form? How can we convert vertex form into standard form? What do you think we can do to this, or how should we do that here? So that's a great question. We have the 4 here, which when you have a 4 in front of parentheses like that, what operation is that? Multiplication. But then I also see something else here. What other? So the 4 is there, and we will distribute. What's that? An exponent. Exponents or multiplication, which comes first? Exponents. So we need to square this first, then distribute the 4, right? PEMDAS, right? Parentheses. Well, there's nothing we can do in parentheses, right? Exponents, we can square this, then multiplication, okay? So what does it mean when you square something again? Multiply by itself. What's being squared here? Yeah, if you got to go ahead, Brady. X minus 1 times x minus 1. Okay.
Is there any homework or no? Can you post on classroom or?
Yeah, I'll put up on the classroom. Yeah, I'll put up on the classroom. Yeah. Okay. Oh boy. All right. So now what do I need to do? Now we're gonna multiply it out here. Now we're gonna multiply it out. Okay, and you have some choice. Kaylee, we could distribute like you wanted to here. The 4 would distribute to the x and the minus 1 here. Your choice. I'm going to multiply the x minus 1s together first. Okay? So I'll leave that as 4. Parentheses. And then I'll do x times x minus 1 minus 1 times x minus 1. Okay, there's a lot of parentheses going on here. I don't know if this is the best way to do it or not. Yeah, it's pretty hard. Okay, let me ask you this. If I let me do it a different way over here. So I'll do it slightly different over here. Let me see which one you guys like more, because I'm okay doing it either way. So in this one, okay, so I'm doing the same problem, right? Same problem. This one I multiply the x minus 1s together first. But in this one, if I multiply the 4 first, do you like this better? Is this better or is this better? What do you prefer? And this one I multiply the 4 first, and then I'll multiply these two together. Or do you like this one more? Do you like this one or this one? You like the left one? Okay. All right. What about for the right one? Do most people like the right one? You prefer the right one? You already wrote the first one, so let's just go. I'll do both. How about that? I'll do both, okay? So for those you like the first one, if you like the second one, then you can tune me out. I can't believe I'm saying this, but go ahead and tune me out. If you like that second one, we'll come back to it. All right, first people, okay? First way people. So I distribute the x minus 1 to the x and the minus 1, so this is what we get. I got to distribute one more time here, x times x times minus 1 times x, minus 1 times minus 1. I still have the 4. X times x is x squared, minus x plus 1 plus 9 there on the end. Okay, so is that making sense? I did x minus 1 times the x, that's right there. I did x minus 1 times the minus 1, that's right there. Then I had to distribute the x, and I had to distribute the minus 1. Okay, x times x is x squared. X times minus 1, minus x. Minus 1 times x, minus x. Minus 1 times minus 1, plus 1. Okay, I can combine like terms inside the parentheses here. Minus x, minus 2x, plus 1, plus 9. And now what can I do? What should be the next step here? Distribute the 4 to all three terms there. So I get 4x squared minus 8x plus 4. It is tricky. Yep, that's right. All right, is that it, or can I simplify any more? Simplify. What goes together? 9 and 4. So 4 and 9, 13. And that is now in standard form. Whew. Okay. Now, that's the first way. Any folks that were following along with that, any questions on this way?
No.
All right, if you were following along with this, you can tune out, and then everyone else, tune back in now, okay? Tune back in. If you were looking at this method, tune back in. Here we go, okay? So again, I distributed the 4 first. I have this. These now multiply together. So I'm going to do this times the x, and this times the minus 1. And so I'll get x times 4x minus 4, and minus 1 times 4x minus 4. Bathroom, Ethan?
Yeah.
I think we're good. Do we have anyone out, Mr. Steve? I don't think we have anyone. Go ahead. I think we're good too. Okay. If I'm wrong, it's okay. That's right, because Brady went to orthodontist. Okay, so again, I'm just distributing 4x minus 4 times the x, 4x minus 4 times the minus 1. Okay, well, we'll distribute one more time here. Okay, I get 4x squared minus 4x, okay, from that, minus another 4x plus 4 plus 9. Okay, so I distributed twice there. Okay, do we have any like terms that we can combine here? Yes, what goes together? The 4x with the? Yeah, so minus minus becomes minus 8. So minus 8x. And then what else goes together? 9 and 4 makes 13. And look at that, we got the same answer. Okay? Okay, that's some pretty intense algebra right there, folks. That is some pretty intense algebra for sure. Okay? Questions on any of that? Any questions there? All right, got some more papers here for you. I know this is like crazy, but what I'm going to give you now, okay, is going to be super helpful. We're going to summarize our 3 methods here. Okay, we're going to summarize our 3 methods, and then I'm going to give you homework from this. Okay, so yeah.
My whole mind is going to be thick as a book. But
I know. Think of all the knowledge that's in there. Yes, both of those. Actually, would it be helpful if I did one and you did one?
yes.
Okay.
Holy cheese was
Might just go a little quicker.
Okay. Yep. No, that's fine. Mm-hmm. All right. Take one, pass it down, please, sir.
You need to save the trees.
Take one, pass it down.
They
These
give
trees are
us
already dead.
oxygen.
Oh, wow.
Take one, pass it down. Okay. Look, I get it, guys. I understand.
We use like
That's okay. I get it. I feel bad. Don't get me wrong. When I'm making these like millions of copies, I'm like, the children are all going to be choking. So this is going to be a nice summary. This is going to be a nice summary for you. Okay, Lauren got one too. Steve, I'll leave one on your desk. Oh, thank you. Okay, so we're going to do our little summary here. So you should all have this paper, yes? Oh, what paper? This paper. Okay, I'm going to quickly go through this. This is going to be a great summary for all of you. Okay, again, tomorrow we will review, but you'll be able to use this tomorrow as part of your review. Okay, and then Friday will be a quiz. All right, so now we're going to put all three forms together here. We'll start with standard form because that's where we started in class. It is y equals ax squared plus bx plus c. Okay? Do you remember how did we find the axis of symmetry from standard form? What did we use? Sky?
We did negative b divided by h, make 2.
Yes, 2a. Yes, it is x equals negative b divided by 2a. Okay? So that's how we did the axis of symmetry in standard form. The vertex, remember, the vertex is going to be a point. This number is going to be the x-coordinate for the vertex, too. So again, you find both the axis of symmetry and the x-coordinate for the vertex in the same number, okay, because the axis of symmetry goes through the vertex. How do we find the matching y value? What do we need to do with this x value? Yes, plug in the x value to get the y value. And that will go whoop, right in there. Okay, that's all you got to do. All right. I'm going to hold off on the miscellaneous stuff for right now. I'm just going to get this important information out to you, which is the axis and the vertex. All right, let's go to vertex form. Next. Sorry. I can show you both here at the same time. Vertex form is y equals a times x minus h quantity squared plus k. This is what we talked about yesterday. Okay. It's called vertex form, right? Let me skip to the vertex here. What are the coordinates for the vertex in this problem? H and k. Exactly right. Remember, this says minus h, but we do the opposite of that, so it's going to be just h. And then plus k, we keep it that way, k. So then what's our axis of symmetry? It's going to be x equals what? H. The x coordinate there. Yeah, it's that simple. Okay? And then last but not least, intercept form. Okay? Intercept form, that's what we just talked about, so hopefully this is mostly fresh in your brain. Okay? It's x minus p. Oops, I'm kind of... And x minus q. Okay? How did we find the axis of symmetry for intercept form? What did we do? You remember? Q plus p divided by 2. So x equals, or I'm going to do p plus q here just for alphabetic sake, but you can do q plus p, same thing. Okay, perfect. But guess what? This x value, it's also the x value of our vertex. And once I have the x value for the vertex, how can I find the matching y value? Plug it in. Plug in the x value to get the y value. And right there is where we're going to put it. Okay? There's our summary, folks. And of course, once you have the vertex, make a table, plot the points, you got your graph. All right, your homework, I want you to do numbers. Oh, goodness.
The whole thing.
No, not the whole thing.
Pressure credit.
1, 2, 3, 4 on the front. Okay, 1, 2, 3, 4 on the front, please. 1, 2, 3, 4 here on the I can graph quadratic functions in intercept form. Okay, 1, 2, 3, 4, please. 1, 2, 3, 4. If you can use it, Kaylee, and you're not going to lose it, then you can keep it. Okay? All right, if you guys want to line up, that's fine. I get it. I didn't leave you very much time. That's fine.
Thank you for letting me borrow it.
You're welcome, okay? Max, do you have one or you don't
I
have
do.
one?
I'm just literally the most forgetful person on the planet.
Okay.
I need to remind myself.
So like set an alarm in your phone or
Yeah,
something like that?
yeah,
That's what I
I'll have to
suggest
do
you
that.
do.